Welcome to EPG Pathshala. Myself Dinesh Ranjan Pradhan, working as a scientist at InfluMnet Center, Gandhinagar. Today we will discuss about semantic web and digital library in this module in the paper Digital Library Objectives. Semantic digital libraries facilitates the usefulness of traditional digital libraries by exposing the content of the digital library through a structure and interrelated web so that it can be easily used by both the machines and the users. So this module will discuss about the core services that can be enabled using a semantic digital library, the architecture of semantic digital library from various perspectives, and example of some semantic digital library initiatives. Introduction. Most of the digital libraries facilitates the searching through RDBMS, that is the Relational Database Management System, which stores the metadata information of the digital library content, or using a full text index to allow searching of the content of the digital library. These methods are helpful in browsing the digital library or retrieving the results by making a query based on the terms that are indexed from the digital objects. But for retrieving results of queries where the query term is not included in the index terms or the metadata of the digital objects, for example, an user is looking for a book on orchids authored by Rolf in the digital library, having a book on vanilla authored by Rolf will not get the desired results. So this is where the addition of semantics to a library can be useful. Semantic information represented by metadata attached to each object and by one or more ontologies to provide semantic context for searches can be used to resolve just such queries. The additional flexibility and search capability represented by such a technique make a semantic digital library much more valuable than a traditional digital library for an average user. The problems in digital libraries. Sebastian Crook pointed out three major problems faced by the digital library users. Firstly, the users are missing a librarian, that is the problems with information discovery and understanding complex metadata of the digital library. They are missing peers, that is they cannot share experience with other users visiting the library, missing connection with other sources. Library resources cannot become a part of the information process workflow. So semantic digital library provides the option to make the digital libraries more useful in today's interlinked web by making the unstructured data machine readable. So semantic digital library services. The major goals of a semantic digital library is to integrate information related to digital library objects available from various sources like bibliographic descriptions, user profiles, bookmarks, or controlled vocabulary. Semantic digital libraries should allow for reuse of objects. This can be achieved using semantics providing meaningfully connected information. It should also enable interoperability with other systems including digital libraries and other services. Major goals of a semantic digital library is to provide search, browsing, and recommendation services, provide services for augmenting resources, provide dissemination and notification services, to provide security and policy assurance services, to give services providing interoperability, providing preservation services, providing quality assurance services, and integrated documentation. Now let us discuss about all these services in detail. Search, browsing, and recommendation services. The major objective of a semantic digital library is to provide information discovery that is superior to the services available in current digital libraries. It should facilitate the users to find out interconnected information about resources available in the digital library while browsing, filtering, or finding similar information objects. Query refinement engines should use complex semantic relations between results to provide search result matching users' profiles. Semantic digital libraries should also provide recommendation services, for example, based on the context and resources annotations or based on collaborating filtering. The search engine should allow for exploiting information about different media types, complex objects, streaming, and spatio-temporal resources. In the case of resources with complex annotations, it is important to support context-based search together with similarity search algorithms. In the case of heterogeneous competitive networks of content provider, the semantic digital libraries should implement query trading algorithms to support the users in their searching. Services for augmenting resources. Semantic digital libraries can augment the stored digital objects by providing additional annotations along with basic metadata provided during the upload process. This can be achieved by both automated and user-based annotations. The user-based annotations can be achieved by utilizing the power of social networking sites where community annotations, tagging, and ranking are done by the users. The annotation services should be flexible enough to adapt to various user groups and content being augmented. For example, time tagging stream media or annotating regions of interest in images and geospatial resources. User-based annotations are the key technology to actively engage users in the process of sharing knowledge. Semantic digital library services should ensure that users providing annotations benefit from better recommendations and search results. Dissemination and notification services. Semantic digital libraries should enable the users to access the metadata in any format and through any services. The users should be able to access the content's metadata by constructing mashups of services and content. These metadata should be provided through APIs as a customizable RSS and atom feeds, SIOC, that is semantically interlinked online communities, descriptions, RDF graphs, and in JSON format. To enhance the user experience, extensible and customizable notification services can be provided as a part of information retrieval process. Security and policy assurance services. Semantic digital libraries should adapt to various policy enforcements and provide flexible authentication and access control mechanisms for convenience of the users. The authentications can be provided through identity federation like OpenID, security assertion markup languages, that is SAML, extensible access control markup language, that is XACML, Shibboleth, Athens, WS Federation, etc. Services providing interoperability. The semantic digital libraries should provide interoperability standards for content, metadata, services, and protocol standards with both backward and forward compatibility. It should provide services compatible with both legacy standards, for example, DNST Z39.50, OAI PMS, and modern protocols like SparkWell and OAI ORE. Preservation services. Semantic digital library should ensure versioning, archiving, that is backup and recovery, as well as provenance tracking, especially in the context of open world approach of semantic and social technology, and keeping track of history of events related to information objects. Quality assurance services. Semantic digital library have to ensure efficiency, security, and semantics of maintained metadata. Integrity documentation. Semantic digital libraries and the related services are mostly complex in nature. It is a vital requirement for the perspective of the library usability to deliver documentation integrated within the digital library system. Semantic digital library architecture. Crook and his co-authors have provided the architecture of semantic digital library from three perspectives. One is top to down layered architecture, second is vertical architecture for core services, and stack of enabling infrastructures. So this architecture has been derived based on the metadata perspective and user perspective of semantic digital library. So first we will discuss about metadata perspective. The digital libraries should make the metadata more open, unstructured, and highly interlinked to assist users in information discovery in the connected information space. The semantic digital library architecture should include annotations contributed by the users in addition to the metadata descriptions provided in traditional digital library. Ontologies are one of the key technologies to semantic digital libraries that enable reasoning over interconnected concepts, provide the meaning to the information objects and to the relations between them. As such, the metadata become a network of meaningful interlinked concepts which can be used by the digital library management services to leverage the usefulness of the content from the perspective of the end user. User perspective. Semantic digital libraries pose requirement for new information discovery and management technologies and provided features like highly extensible faceted navigation, natural language based interaction, or community driven collaborative filtering, etc. The contemporary users interaction models, for example Web 2.0 or instant messaging, has to be included for users. Benefits that users can derive from semantic digital libraries have to be delivered as enriched services over and above what is being offered to him or her by the contemporary solutions. In the semantic digital library, user profiles can be captured with a special ontology that describes characteristics, groups they belong to, and the relationship with other users. Semantic digital library DLMS can select only the desired part of information and process it to deliver a given functionality for a specific user. It becomes especially feasible with the underlying unstructured metadata and ontologies. Crook in 2009 has given a layered architecture for digital library management system, which is composed of 6 layers. The lower layers of the figure that is on your screen are more data oriented, and the upper layer provided the requirement of the end users and external services. The service oriented architecture is proposed to specify, organize and execute services delivered by each abstraction layer. The 6 layers are client layer, data presentation, data preparation, data manipulation, data abstraction layer and data source layer. So first the client layer. The client layer represents applications used to access the digital library content, which include graphical user interface available through web browsers or mobile browsers, programs that process the content for their own purpose, or mashups that consume the content and provide through an integrated portal or services. Data presentation. The data presentation layer represents the endpoints which deliver the raw content to the client layer application and services. The data in this layer is expressed in different levels based on the standard of encoding, like some formats require more information and processing, while other can be directly sent over from the underlying the RDF storage. This layer shows the benefit of using RDF object model and ontologies to define meaning of concepts and relations. In most cases, a user does not need to know the particular schema in advance. If necessary, the specification required for transformation can be derived from these ontologies. In some cases, it is just a matter of reformatting the information to other standards like JSON. This layer assures that information model using concept of ontology can be translated and tailored to fit understanding of other users and client services. Data preparation. This layer is quite different from the previous layer and acts as a checkpoint for the delivered content. It does not directly manipulate the data, but represent the data based on various policies and user requirement, or ensure the consistency of the data and augment with additional information from the same library or other services. Data manipulation. The data manipulation level is the most developed layer of the semantic digital library model. It retains the core mechanisms responsible for delivering particular libraries functionality to the end user. The layers above process the data to fit the appropriate client needs, while the layers below provide means to perform operations needed to fulfill a given service goal. Details about this layer is explained in the business logic services layer. Data source layer. The data source layer represents the data repositories used for semantic digital library, which include RDF storage for metadata storage and conventional storage for binary form of the resources. It also includes full text index storage and separate services required for managing distributed and local data. The vertical architecture of business logic services. The data manipulation services layer of semantic digital library are represented in 4 vertical layers. These 4 layers are based on the role that they play in interaction with the end users in the semantic digital library. One is the information discovery, that is access, search and browsing. Second is the advanced management services. Third is basic services. And fourth is interoperability services. Information discovery, access, search, browsing services are the services the end users interacts with most often. The services implemented in this column range from enhanced search and browsing natural language interfaces, faceted navigation to community services such as annotations, ranking, collaborative filtering, and collaborative search. Additional services support context-based operations, user profiling, and overall quality of the services. End users can also interact with the digital library management system to compose workflows to support their business needs. This layer includes collaborative search, collaborative filtering, annotations, ranking, natural language annotations, faceted navigation, natural language interface, query processing, search and browsing, context or profiling, quality services, and workflow composition. Advanced management services. Advanced management services are mostly accessible by the librarians and library administrators. They deliver service, user, collection, and streaming media management. Librarians can also manage the set of ontologies deployed in the semantic digital library. They can also invoke ontology learning process on the corpus of recently added resources. Streaming media management, service management, user management, collections maintenance, ontology management, and ontology learning are the parts of this service. Basic services. Basic services support core operations of the semantic digital libraries such as content and metadata management, ensuring access and policy management. A set of basic services support librarians in the classification process by the indexing, feature extraction, and recognition operations. These services include content management, access, metadata management, event notification or logging, rights or policy management, recognition, feature extraction, classification, and indexing. Interoperability services. Interoperability services are farthest from the end user but close to the external services. To support interoperability, semantic digital libraries can offer different solutions. They range from simple exposing metadata and SPARQL endpoints to metadata harvesting solution, for example OAI PMH, to service and metadata mediation services. This include expose metadata, metadata mediators, service mediators, and harvesting. Stack of core technologies architecture. This section provides the architecture from the technology perspective in which all the previous layers operate. So first is the service-oriented architecture. The service-oriented architecture suggests for providing the services of semantic digital libraries using web services, which facilitates effortless integration of digital library services in outer online services or mashups. This includes both the REST and SOAP services, peer-to-peer. The peer-to-peer network infrastructure is used for data processing distribution. It is commonly used to create a distributed index for data stored on different machines. Grid. The grid networks are mostly used for heavyweight data processing tasks. The grid infrastructure can support digital library in execution of the most of heavyweight operations like query processing, which is to be executed at the runtime, converting resources, processing annotations, and indexing that can be executed behind the scene. The semantic digital library should not deliver new features at the cost of lowered system efficiency. Therefore, grid networks can support processing annotations and semantic web languages query processing to maintain overall system performance. Semantic web digital library projects. So several semantic digital library prototype or tools have been developed in different part of the world. So we'll discuss a few examples like Jerome Digital Library Projects, BRICS Digital Library Infrastructure, Marcont Initiative, and the SMILE project. Jerome Digital Library Project. Jerome DL, a digital library that deploys semantic web technology for user management and search with an aim to provide personalized services to the users based on the user's profile. The FOAP vocabulary is used to gather information about user profile management, and semantic descriptions are utilized in the search procedure. Jerome DL is implemented in Java and is available under an open source license. The main components of Jerome DL system consist of resource management, retrieval features, user profile management, and communication link. In resource management, each resource is described by the semantic description according to the Jerome DL core ontology. So additionally, a full text index of the resources content and Mark 21 and BibTeX bibliographic descriptions are provided. Each user is able to add resource via a web interface. To satisfy the quality of delivered content, each resource uploaded through the web interface has to be approved for publication. The administrative interface for librarian, that is the Jerome admin, allows to manage resources and associated metadata, that is Mark 21, BibTeX and semantic annotations, as well as to approve user submission. In retrieval features, Jerome DL provides searching and browsing features based on semantic web data through a 3-step search algorithm. In the user profile management, it provides additional semantic description of resources, scalable user management based on FOAP. Communication link component provides communication with an outside world, which is enabled by searching in a network of digital libraries. The content of the Jerome DL database can be searched not only through the web pages of the digital library but also through the digital libraries and other web applications. A special web services interface based on the extensible library protocol has been developed for this purpose. BRICS Digital Library Infrastructure. BRICS, that stands for Building Resources for Integrated Cultural Knowledge Services, is an European project which aims at enabling integrated access to distributed resources in the cultural heritage domain. The target audience for BRICS is broad and heterogeneous in nature and involves cultural heritage and educational institutions, the research community, industry, and the general public. The architecture of BRICS Digital Library System is distributed in nature, and rather than managing contents and the metadata in a centralized system, institutions have the possibility to install a B node for bringing in their contents and metadata into the BRICS network. Each B node instance provides a set of services which cover the major functionalities like DRM or user management required by each institution. Marcont Initiative. Marcont Initiative is an initiative to create a new bibliographic description standard in form of an ontology and related tools utilizing semantics technology. The goal of the Marcont Initiative is to create an ontology which would have potential to become a standard for describing data in semantically enabled digital library systems. It was created to address 4 major requirements. The ontology should be compatible with at least Mark 21 concise format for bibliographic data. Marcont ontology should be written using OWLDL, that is Web Ontology Language Description Logics. Semantics description should be easily translated to Mark 21 or Dublin Core formats and possibly any other format. It should be possible to merge Marcont ontology with other bibliographic ontology. And the last one is the semantic interoperability of metadata and information in unlike environment project, that is the SMILE project. The semantic interoperability of metadata and information in unlike environments project was jointly conducted by the MIT Libraries and MIT CSAIL, and funded partners are included HP Laboratories and the World Wide Web Consortium with support from the Andrew W. Mellon Foundation. SMILE sought to enhance interoperability among digital assets, schemata, vocabularies, ontologies, metadata, and services. A key challenge it solved was to make collections interoperable, which are distributed across individual, community, and institutional stores. By drawing on the assets, schemata, vocabularies, ontologies, and the metadata held in such stores. Summary: semantic digital libraries are the next step in the evolution of current digital library management systems. They offer services which exploit the notion of semantics and cater to online communities of the library users to keep up with growing demand on quality of provided services. In this model, we have discussed about the various services that can be provided through semantic digital libraries and the core architecture in creating a semantic digital library and examples of some semantic digital library projects. Thank you.